is wrong, I'm happy. It makes sense. 1, 2, 3, 4, 5, 6, and that's where it should be, 75, somewhere here. And it will go, of course, asymptotically. That's how it should go. That was my problem. I cannot plug in. Okay, so I'm going to erase this because it's a little bit lower as expected. Of course, it makes no sense to be up there. It cannot be because it has to approach asymptotically. Okay, very good. Thank you. You saved me from myself. So this is f of x, which is x cubed over x plus 1 squared. Thank you very much. And yes, when you graph this function with a graphing calculator, I want to show that. Thank you for saving me. Okay, careful how you enter. Make sure that you don't have anything in StatPlots. I worked with my stat class. Okay, so that's off. So now in y equals, when you enter it, please careful with parentheses, power 3, and divide by, in parentheses, x plus 1, and that is squared. You must enter the slant asymptote. The calculator will not enter it for you. Okay, so I'm gonna do I know that the standard view English window should work. I can make adjustments later. Here it is. Yes, yes. Okay, so here is, right here, -1 is the vertical asymptote, opening down, inflection point, up, asymptotically, closer and closer. That's the meaning of the word, asymptotically, closer and closer to the asymptote, closer and closer to the asymptote, closer and closer to the vertical asymptote. So you must put in the slant asymptote. You have to find it. Thank you.
Can you do an example of synthetic division? Just review it.
The long division?
Synthetic division.
Yeah, the synthetic division works only when we divide by x minus a number or x plus a number. So just give me any example and let's look at the synthetic division.
I don't have a definitive example. I was hoping you might, just because I do not remember synthetic division at all.
Just create a polynomial and any degree, and we will divide it by x plus 2. Any polynomial we want.
3x to the 4 minus 2x squared plus 3x plus 4.
Perfect. Perfect example. So we're talking about the synthetic. Synthetic division. So the algorithm requires us to, so first of all, synthetic division has limited applicability in the sense that the denominator must be x minus a number. So this is, in this case, we have x minus -2, so a is -2, and that fits in this box. So a has to be in the box. I have to identify it by comparing x plus 2 with x minus a, so a is -2. If I have x minus 3, then a will be 3. If I have x plus 2, then a will be -2. In the next step, first of all, we have to make sure that the polynomial is in descending order. Mandatory. Degree 4. Degree 3 is missing. Degree 2 has coefficient -2. Degree 1 has coefficient 3. Degree 0 has coefficient 4. We bring down degree 3, or the leading coefficient. -2 times 3 is -6. We perform the addition, -6. -2 times -6, and we write above the line is +12. we perform the addition. Negative 2 times 10, we write the number at the above. Negative 20 plus 3 is negative 17. Negative 2 again times negative 17 is 34. And then we box in the remainder, which is 38. Since we divided degree 4 by degree 1, this is corresponding to degree 3, and so on and so forth. So the answer would be 3x to the third minus 6x squared plus 10x minus 17 plus the remainder of 38 over x plus 2. And that's the synthetic division. But it has limited applicability. We could have not used it in this case because the denominator here was not x plus a number or x minus a number. It was x squared plus 2x plus 1. Very good question. Anything else? So the only, I know I have just a few minutes left. I just wanted to show that example in which we have, I just gave an example a second ago right here. So this is x plus 1 and x minus 2 over x minus 3 and x minus 2. So in this case, we do simplify, but we cannot simplify before we state the domain. We can only simplify after we state the domain. So now these two go away. However, the function is still undefined at 2. So the simplified form of the function will be x plus 1 over x minus 3. And the whole will be f of 2. But you can say, but you cannot plug in 2 here. No, I cannot. That's true. But I can here. So 2 plus 1 will be 3, and 2 minus 3 is negative 1. So this is negative 3. So the whole will be 2, comma, negative 3. And x equals 3 is still a vertical asymptote. So when we review next week or the following week, I'll show another example with a whole. And we'll go through all the steps of graphing. But that's the only thing. So this will be a rational function. I'm not graphing the function. But at 2, negative 3, the function will pass through this open point. 2, comma, negative 3. So it probably will be like this, or it will be with a horizontal asymptote. The horizontal asymptote is positive 1, so so it will be something like this. I just wanted to make sure that you see these before we finish the semester. They're at the very end, as I said, of this section. Where is my... So they're at the very end of this section with the slant asymptote. So I don't know if this new book has examples with a whole or not. I don't know, to tell you the truth. But that's a very important possibility in which the function has the factor. If a factor simplifies, then it will be a hole in the graph. If the factor does not simplify, like x minus 3 does not simplify with a factor of x minus 3 at the top, in that case, this will be a vertical asymptote. Will stay as a vertical asymptote. Very good. Any questions for me? There is absolutely no more new material. This is it. We completed absolutely everything for the class. My intention is to post test 4 with solutions an old test for with solutions, so you can look at it. And I would like us to review the entire session. What you should expect, for example, for this test. Again, a short test. Number one, anti-differentiation. Number two, the limit of the Riemann sum. Not for a super sophisticated problem, but you have to show all the steps. Definite integrals, indefinite integrals, substitution, fundamental theorem of calculus, properties of the integrals, of the definite integrals. That's about it. And the net change theorem. I can't think of anything